So this is section 12.2, computing compound interest. So for example, it says if a total $100 is deposited in a savings account paying 10% annual interest, the interest earned after 1 year will equal 100 times 0.1, which equals $10. So the total amount of money in the account would actually be $110 because we take 100 times 1 and then 100 times the interest to find out the combination. Okay, so each year the money in the account increases by a growth factor of 100 or 1.10 because we take 1 plus the interest. So after X years it would be 100 times 1.1 to the X, and this is called the compound interest, okay, for exponential growth. So here is the format that we use for compound interest so that you can put in your principal or your initial amount. R is your interest rate in decimal, and then T is your X, which is your number of years. And so the growth factor would be the 1 plus R. So the compound interest formula takes the form of an exponential function with A equal to 1 plus R. Okay, so if we look at an example, here's a 20-year-old worker. He deposits $2,000 in a retirement account that pays 6% annual interest at the end of each year. So they want to know how much money is in the account when he's 65 years old. What is the growth factor? So again, we know that he invested $2,000, that's all he invested, and his interest rate is 0.06 because it's in decimal form, and we go to 45 because we take 65, how old he is when he retires, and then we minus 20 to give you the 45. So now you put it all into the equation. You get 2,000 times 1 plus 0.06 to the 45th power, and so now you'll have in 45 years $27,000 529. Okay, so this is how much you have later on. So this is a really important piece so that you can do your own kind of investment down the road. So let's look at page problem 67, which is on page 836. So I'm going to make that 36. Okay, so we're doing 67. So 67, it's the same idea. We have a 1,500, 9%, and it's 10 years. So let's go to screen, and for 67, okay, we know that P is going to be 1,500. We know that R is going to be 9%. So we'll change that to 0.09. And then we're knowing that the time frame is about 10 years. So we have the formula that they gave us, okay, which is A equal to P times 1 plus the R to the T. In this case it'll be X. Okay, so we know that we started off with 1,500. 1 plus the 0.09, and that's going to go for 10 years. So we have to combine what's in the parentheses first. Okay, now we'll do the exponent, so let's do that on the calculator. So it's 1.09 to the 10th power. And then we're going to multiply that by $1,500. And so you're looking at 3551.05, let's say. So we get 35, right? 3551. So 3551.05, and that's basically the amount of money that you would have after 10 years. And so in essence, you think about it, how much did I actually get from my $1,500? I could subtract out the $1,500, and so that would tell me basically how much interest that I made over the 10 years. So I made about $2,000, and that was just investing one time of $1,500. So think about if you did this over a longer period of time. That would make it more interesting. So that's the basis for that. Let's go back to the book and let's take a look at that. Let's go back to page 830. Okay. And so interest paid more than once a year. So sometimes people don't just get paid once a year, they get paid semi-annually every year, or they get paid quarterly every year, or they get paid every month, those kinds of things. So that's something that changes. So we have a new formula for this. It's now going to be the interest divided by how often it is paid, and then it's also n times the t for the annual interest for the number of years of payments. So let's take a look at that again under the drawing here. So we're going to have a new equation that's slightly different from the one we just did. That's going to be A equal to P times 1 plus the R over the N, and then that's N times the T. So if we do semi, that's going to be twice a year. Okay, 2 times a year, I should say. Okay, so 2 times a year, and then we have what people might hear of is quarterly. So quarterly is 4 times a year, so this would be the N, or we could have it monthly, and that would be 12. Okay, and so these are the different things that you might hear about. So semi-annually, this is semi-annually, and this is quarterly, then monthly. You could do daily, but I don't think anybody does daily. Okay, but those are the different forms, and so you have to pay really close attention to the story to know which one you're going to use. So like for example, this one's a total of $1,500 is deposited. It's paying 6% annual interest. Okay, compounded monthly. So once we hear monthly, that makes the N 12, and so that's what we do there instead. That's the only slight difference that we see in these particular problems. So it's not a huge change, but something to pay attention to.